So today we're going to take a look at how do we solve probability when we have dependent events. And this is going to be a little bit of challenging. We're going to take a couple days to do this lesson and to be able to understand it. So one of the first things that we're going to have to look at is how do we decide is it an independent or dependent event? So basically a dependent event is where the occurrence of the second event does depend on the first event occurring. And the way that sounds or looks like when you're reading a problem is there's this conditional probability. And this is going to be kind of the key part when trying to solve questions on this. And the key word is the word given. So when you see the word given or you hear it when you read it, that's where that slash means. So when you hear B given A, that's the notation that you're going to use when setting up your probabilities moving forward. And we're going to do that a couple times moving forward. There are some times when we're going to solve for B given A, the probability of that. And then there's some times where we're going to be actually provided that information to be able to solve for the two events occurring at the same time. So when looking at this, there's two formulas. These are the same formulas. All right, just rearranged. So sometimes we're going to be using this formula, A and B equals probability of B given A times the probability of A. Or there's sometimes we're going to solve for this, B given A, given where it's probability of A and B divided by the probability of A. But one of the key focuses here is your dependent variable always has to be B, and my independent variable always has to be A. So keep that in mind as we go through this lesson, because that's going to be important to be able to define these things moving forward. All right, so given is where that little slash is. All right, B is the dependent variable, A is always the independent variable. And if we can keep that in line, the math is going to take care of itself, but it's the literacy that gets in the way of the numeracy. So let's look at a question here. The probability of Mr. Brzee being tired for his class is 35%. The probability of Mr. Brzee making a mistake in his lesson given that he's tired is 73%. And the probability of Mr. Brzee making a mistake in his lesson given that he's not tired is 29%. Okay, so one of the things that we have to take a look at is what are my two variables? Well, the first variable is being tired, and the second variable is making a mistake. So you have to look at, say, well, what depends on what? And it kind of goes back to our thinking before. And here's this word given. When you guys are trying to answer some of these questions, write on the question. Physically write where you have your B and A. So my being tired is A. Me making a mistake is B. And the reason why this is my dependent variable, because making a mistake depends on me being tired or not tired. Okay, so we actually have to define these variables as well because we don't know what we're trying to compare. So it gets a little bit complicated, but take your time and write out these. All right, so when I'm looking at my probabilities, I want you to show this work 100% of the time. Write down what you know. The probability of being tired for class, so that's A, is 35%. So we know that the probability of A is 0.35. So we're going to write that as a decimal. So check mark. Second part is the probability of making a mistake, there's my B. So it's in this lesson, given, so that's where that slash comes in. Be tired is A, is 75%. So this is the next thing that I know. Okay. And the probability of B making a mistake, B, given not being tired, so that's A prime. All right, I'm going to write this down here and leaving a little bit of room for that. So that's 29%. Okay, so all that information we've written down so far is what we've taken from the equation or from the problem. The next thing we need to know is some of these complements. Okay, well, we know that the complement of that is 65%. So the complement has to be A prime. All right, so compatibility of me not being tired on any given day is 65%. Now, if we look at this, the complement of that is 27%, and the complement of that is 71%. Okay. So when I look at that, the question now is, what's the notation? Well, my notation for this guy is that before it was making a mistake given he was tired, 73%, while the probability of me not making a mistake, so B complement, given A is 27%. Likewise, the complement is me not being tired, given, or not making a mistake, given I'm not tired, is 71%. So there's actually 6 different probabilities that we can take from that question moving forward. All right, this is the key information. So for the setup for this question, do this all the time. This, the black, the blues were all taken from the question. The purple and the green were the complements of those. Okay? So that's the key for the setup. After that, everything falls from that. Okay? So now we don't even have to look at the question, the information. We know all the information. So, just so that we know, A is tired, A prime is not tired, B is mistake, and B prime is no mistake. Okay, so now when read the question, write on the question. So the probability of me being tired, that's A, and making a mistake is B. So now what I can do is I can go to my question now. This is what I want to find. All right, so this is the given formula. That's supposed to be B, my fault. Is the probability of B given A times the probability of A. Now I just look up to find the numbers. Okay, so B given A is 73% times 35%. Okay, so I can go 73 times 35. That is 2555. That's it. So the math is easy. The setup is hard. So I've made the math easy. by using our English skills. All right. Second question. So I'm going to use green here. The probability of being tired, that's A, and not making a mistake, that's B prime. So just like we did with our examples with independent probability, carry the complements down for the letters. So, oh, I made a mistake. It should have been B prime there. Okay, so if B is primed in this part, then it's got to be primed in this part. All right, now I look up to find the right probability. So I'm going to look back up. I have B prime A is up here is 27% times A, which is 35%. All right, now I can answer the question, all because I did the groundwork to do that. 0.27 times 0.35. Done. All right. I'm going to push pause here, and what I want you to do is define the letters in the question. Is it A prime, B, or B prime? And then you can check. So hopefully when you checked it, or you checked your answer, not being tired is A prime, and making a mistake is B. So the formula that I'm going to use is the one with A prime and just plain B. Okay, and I'm going to fill in with the right complements if it's there. All right, and then I'm going to look up. All right, it's getting a little difficult, so I keep scrolling up. So 0.29 is B given A prime. And the complement of that is 65%. So 0.29 times 0.65. There we go. All right. And the last one, I'm going to push pause. I want you to try it now by putting in the right letters in there and trying the answer and see if you can compare it with mine. All right. So this is what I've written down. I noticed that it not being tired is A prime. So if I went back to look up top, we had A prime is not tired. B prime is not making a mistake from what I looked up front. Then in my equation, both A and B are prime. Both A and B are prime in my formulas on both sides of the equation. Then I look up and fill in the right information and solve. So that's kind of the thinking that you're doing working through this. Now, I know that this is not here, but if I look at this, all right, if I added up all these probabilities, it would equal 1 because I have listed all the probabilities / outcomes. So they all add up to 1 so that we know that. Okay, so I'm just going to go back and just tell you what I found. Okay, so here I found that, there we go. All right, the probability of being tired and making a mistake is 25.55%, or you can leave it as a decimal, doesn't matter. Probability of being tired and not making a mistake is 0.0945. Okay, so usually when I'm tired, I don't make too many mistakes, or I'm not always perfect, so that's always good. All right, the probability of not being tired and making a mistake, that's still pretty low. All right, is 1885. And the probability of me not being tired and not be making a mistake is the highest, because usually I'm not tired and usually I don't make mistakes. Okay, so those are the things that you want to keep track of as you move forward. So the other example is when we have a chart here. So a recent survey was conducted about their views of the completion of the track. So this was a long time ago because the track wasn't done, but so what? So we have 45 males, 34 females that had a negative view, 22 that are positive, 10 that are positive with a female view. So we're going to take a look at how do we solve some of these questions. And with these types of questions, what we have to do is we have to actually define the independent dependent variable from the actual question, because it could depend. All right, are we looking at males with a negative view or a negative view given that they're males? So there's two different ways we can look at this. So first question, what is the probability choosing a person with a negative view given that they were a male? So here's this word given. So we know that we're asked to find, so here's my formula that we're going to refer to. All right, this is the same formula from the front page. All right, but the key thing here is A has to be the independent and B has to be the dependent. And B has to go in front here. The reason some people do make mistakes when doing this is defining the A part properly. So here, this has to be B slash, I guess A would be here. All right. So when I write this down, my B variable has to be negative view. And A has to be male, based on the wording in the question. Okay, so you take the wording from the question. So all this information now comes from the table. So when I'm solving this, probability of B given A equals the probability of A and B divided by the probability of A. So when we look at this, all this information now is going to come from the table. Okay, so probability of, so the top part means male and negative. Well, if I'm looking at male and negative, that is 45. There's 45 people, but we need a total. We need to divide that out. So let's add up some of these options here. 45 plus 34, that's 79. 22 plus 10 is 32. So if I add that up, that's out of 101. So what? This is, if I add this up, that would be 67 and 44. That adds up to 101 as well. So we know that we have 101 people. It's got to be out of 101. Divided by, now A is male. So that part right there is, we're only look at the total males. Well, how many total males do we have? Well, we have 67 total males. Okay. And a way we can look at this is how to make this a little bit smaller is when we divide out, we can do the reciprocal and multiply. So if you go back to grade 9, when we divide fractions, we do the reciprocal multiply. But basically, you can kind of think of the same thing as a ratio. This actually becomes 45 out of 67. Check mark, done. Okay, so when I'm looking at my table, I am picking out A and B based on the definition of the words. Male and negative view, that's there. And then divided by the total of A. Well, that's 67 out of 101. That's how I can get that answer. Okay, but you have to work on the wording of in the question. If you don't take the wording in the question, you will struggle with it. All right. Second question. Choosing a male given. So there's that word given. So there's my slash. So it has to be B given A. And take a little bit of time and write it out. Male and A is a positive view. Take some time to do that. Take some time to write out the equation. So take that time to write out the equation. Okay. Then I'm going to look back up the table to find my numbers. So when I'm looking at this, the top has to be male and positive. So I'm going to go up to the top and say, well, male with a positive view was 22. So that's going to be 22 out of the 101. Divide by, I'm going to use green here. The bottom part has to be just positive. So I look up and say, well, how many people had a positive view? 32. Okay. All right. And then basically the bottom parts of the fractions go away. 22 out of 32. Okay. If you want to reduce to lowest terms, or if you want to leave it as a decimal, I don't care. Okay. So what's the probability of choosing a male given they had a positive view? Well, that's going to be 68.6875% of the time that's going to happen. All right, because there's more males with a positive view than males with a negative view. It's a comparison. Okay. So your success criteria, if I was going to say, what are the biggest things that I have to do when doing this lesson? All right. All right. Clearly define your variables. clearly define the probability of the outcomes or events by using the words in the problems. All right, so go ahead and write on the question. That's going to help you clearly define those things. All right, and then write down the formula based on given information, and then solve. So the solve part, this should be the easiest step. All right, because the wording is going to make the math easier. That's the goal. All right, so give it a try. All right, the next lesson we'll kind of review some of these things if you're not 100% sure, but try to do your best. All right, take care.